Hey everybody, welcome to Problem Sette number 9, which is brought to you in part by this weather, which is quite fine. There's a free worksheet in the description. Let's get started.
All right, let's try something a little bit different. This question is very, very hard. It takes lots of very common topics that we're going to see on very basic questions on the SAT, things involving triangles and parts of circles, but it's much harder because it's taking all of those things and cramming them into one question. This is a very typical way that the SAT designs its hard questions. It takes basic stuff that you're supposed to know individually and brings it all together for one hard question. So that's okay. We can just take it one piece at a time and we should be fine. But there's a lot of information in this question that we're going to need to put down on our scratch paper to get started. Let's just start by reading it out, okay? The whole thing. A circle has center A and points B and C lie on the circle. Line segments BD and CD are tangent to the circle at points B and C respectively. The measure of angle BDC is 120 degrees. The length of line segment CD is 12 inches. What is the area of the region that is both inside quadrilateral ABDC and outside the circle in square inches? Round your answer, blah, blah, blah. Okay, so my advice whenever we have a long, complicated SAT question is just take it piece by piece. Usually one sentence at a time is enough to build the thing that you need. So here we're going to use our scratch paper to draw this shape. We're going to start with the simplest piece. Let's draw a circle. So I'm going to try my best to make it round. Yeah, not so bad. Okay, has center A and points B and C lie in the circle. So let's just kind of put them in random spots. If I look ahead, maybe I could see if there's anything about B and C that's important, but it doesn't really seem to matter. So I'm just going to pop them like right here and here. That way I just have some points, and now I can continue with the next piece. Line segments BD and CD are tangent to the circle. So that word tangent is very, very important. It is not something you can just overlook when you see it. What it means is we have a line that's going to go through that point, and it's just going to glance our circle, right? So it's going to touch it, but only at that point C. It's not cutting through in two spots like a chord would. It's just going right against the edge of the circle and moving on. So we have another one of those here at B, and they're going to intersect out here at D. Okay, so that's good. We're going to talk more about the tangent in a second, but let's continue for now. The measure of angle BDC is 120 degrees, so I can pop that right in there. And it's kind of small, but you guys get the point. And it kind of looks like, actually, let's make it a little bigger. It kind of looks like it is 120 degrees the way I drew it, maybe a little on the smaller side. But that's okay. So the main thing is, just like if the SAT provided us with a picture, it might not be drawn to scale. If it has that little note that says it's not drawn to scale, that means even if they gave us the picture, we wouldn't be able to trust what we're looking at. It's kind of the overall shape, but maybe the dimensions are not quite right. And so that should be the same as when you draw your own pictures for questions like this, is don't worry about it being perfect. Just try to get the information out there, label things appropriately, and focus on the numbers, not the actual sizes of how the angles are and the lines that you drew. So we have that 120 degrees. Moving along then, the length of line segment CD is 12 inches, so that's here. And I'll put the little inches mark just to differentiate that from the degrees. And that's about it. Now we need to know what is the area of the region that is both inside quadrilateral ABDC. So let's draw that. So that's forcing us to connect these dots. And a quadrilateral, remember, is just a four-sided shape. So now we have one, right? So we have this little diamondy kite-looking thing. But we don't care about that really. We care about the area of the region that is both inside that quadrilateral and outside the circle. That's very strange, but basically what it means is this highlighted piece here. Okay, so it's I don't even know how you would describe that. It's just kind of like a little curvy wedge or slice or something. Not quite a slice, I guess, but it's something, right? So we're not going to be able to get that directly, is the point, right? You don't have a formula for that weird looking thing. So we're going to need other formulas of more familiar shapes, and we're going to need to work our way towards it. And already I've got some clear ideas, but remember there are a few things that you should try to do whenever you have a hard geometry question to move the question along. One of them is draw radiuses. And we already did that because we had to make quadrilateral ABDC. But one other important thing about these radiuses is since they are hitting tangents, we now also know some angles because a tangent line is going to be perpendicular to the radius at that point. So that means this right here is 90 degrees. This right here is 90 degrees. And without really wondering why, I'm going to find the angle right here at angle A because I can. And it's just a really good rule of thumb that if you've got a complicated picture for any geometry question, if you can put something new on it, put it on there, solve it. It probably is going to help you. You might not know why as you're doing it, but long term, it's a good idea. So in order to do that, we need to remember that a quadrilateral has 360 degrees. Let's kind of put that there, 360 degrees in a quadrilateral. So we have 360. We've got the two 90s already taken care of. And then angle D, remember, is 120. So we can subtract those things out. And let's just do that. I've got my Desmos right here. So 360 minus 90 minus 90 minus 120, 120 is 60. So that is angle A. So let's put this aside, angle A. Okay, now why does that help? Well, I do know that 60 is a nice angle. I have some things that I can do with 60-degree angles when it comes to triangles, right? We have 30, 60, 90 triangles. That is something that's on our reference chart. So that might be something I'm going to use. Beyond that, I also know that another good rule of thumb when you have hard geometry questions is to make triangles, because triangles have so many rules. So actually, let's pull that up. Here's the reference chart that you would get on the SAT. Look at how many of these things involve triangles, right? 4 of the formulas are all about triangles. That's a really, really good sign. So the fact that we have so many formulas of triangles reminds us that maybe we should try to make them. And the best way to do it here is to draw another line connecting A and D, okay? Now, the reason I'm doing that is I want the triangles to be consistent. I want to understand them better. Now, I could connect B and C and make some triangles, but I don't know a whole lot of what's going on with that. Maybe there's ways to do it, but this is, to me, more important and more interesting because now both of those triangles are the same. Whereas if we connected B and C, just even based on my picture, it doesn't look like we'd be creating the same triangles. But I know these triangles are the same because I know that these radiuses are the same. And I'll eventually be able to figure that out. But for now, all I care about is that 60 degrees has now been split into a 30-degree angle here, a 30-degree angle here, and that 120 has been split into a 60-degree angle here and a 60-degree angle here. And this is why we know now all the dimensions of all these triangles, because we can use the 30, 60, 90 rule. Notice that this 12 here is opposite the 30 side, okay? So let's put that on our little picture here. So that means opposite the 30 side, that's the 12. So if x is 12, then the hypotenuse is going to be 24 because that's 2 times that according to the formula. And then the other leg is going to be 2 radical 3. So if we go back to our picture, that means this here is 24. This is 12 radical 3, and that's the radius of the circle. So that means all the radiuses are 12 radical 3. So that's here. And then because that's also on the top a 30, 60, 90 triangle where we have now 2 sides and we're missing the third, we can recognize that this is also 12. So we got a lot of stuff here. We're making progress. I might not feel like it, but I promise you we are. So the next thing we need to do is start to think about areas, okay? And this is where it gets messy. We could try to find the area of that quadrilateral, right? That might feel like the most intuitive thing to do. But remember, it's not a nice quadrilateral. It's not a rectangle. There's a 120-degree angle in there, right? In order for it to be a rectangle and use area equals length times width, we would need to have 90-degree angles only. So we don't have that. So we can't use our typical formulas. But again, thinking about triangles, we can think about 1/2 base times height. That seems to work. And instead of thinking about the quadrilateral as a whole, we can think about the 2 triangles that we split it into. So what I'm going to do, this is getting very messy, but we're gonna try our best here, is I'm going to, let's do this color. I'm going to find the area of this piece here. So you can see it's in pink, it's a triangle. So let's give it a shot. So that's going to be area of a triangle is 1/2 base times height. And remember, in order to find the area of a triangle, the base and the height need to be perpendicular to each other. And since this is a right triangle, we already have a right angle to work with. So we can use the 12 as the height and the 12 radical 3 as the base. That's kind of how it's oriented. And then just let's multiply. So 1/2 of 12 is 6. So 6 times 12 is 72 radical 3. So that is the area of one of the triangles. But there's 2 of them in our quadrilateral, right? So let's multiply that by 2. So then A, B, D, C, that quadrilateral, I'll put some boxes around it, is equal to 144 radical 3. So that's good. We're making progress. But this, I think, now gets us to the very hardest part, which is, all right, we have the quadrilateral, but we don't want all of it, right? We just want the part that's outside the circle. How do we get rid of the part that's inside the circle? Well, now we have to think about what I would call a slice, or what some people will call a sector. So sector or slice, basically, we have to think about, this is so hard to draw, the part here that is anchored on that center of that circle. So we want to subtract that out, right? This whole quadrilateral that we found is 144 radical 3. So if we can subtract out the slice, we're going to be left with the shaded area that we want, okay? So we need to find the slice. And I always think about slices in terms of the formula part over whole. Because basically anytime we have like a slice that's anchored on the center of a circle, we can just think of that as a fraction of that circle. And that fraction always has the same kind of relationship between the part and the whole. So think of like a pizza. A pizza is circular. If you ate a quarter of the pizza, you'd eat a quarter of the sauce, a quarter of the cheese, a quarter of the crust, a quarter of the toppings, right? It's consistent. So the same thing is true when we have just a plain circle like this that you can't eat. It's still got a quarter of that circle. It's going to have a quarter of the area, a quarter of the circumference, a quarter of the degrees. But here we don't have a quarter. We have 60 degrees out of 360 degrees. So that's 1/6. We could think of it that way, but I'm going to leave it as 60 out of 360 for the sake of simplicity, right? So that is us focusing on this angle A again, which it's kind of buried now in my drawing, but right here, remember, it's 60 degrees for this angle here. So we can compare that to the area of the whole circle. So the sector area that we're looking for is what we want to subtract. That's this slice that we want to get rid of. So we need to relate that to the whole area, which we can get because we know the formula for the area of a circle is pi r squared. We have the radius of the circle is 12 root 3. So this area is pi times 12 root 3 squared. So that's pi times, remember how to square a radical like this? You square both parts. So one is going to be 144 and the other is just going to become 3. So 144 times 3, that I don't know off the top of my head. So let's type that in. 144 times 3 is 432. So that is the area of our entire circle is 432 pi. So that goes down here, 432 pi. And now we need to cross multiply and divide to get the area of the sector, right? We have 3 parts of it, and we have a way to solve for the 4th part, the missing part. So we can cross multiply and divide. Here's where I'm just going to take a little bit of a shortcut and just reduce this to 1/6. And so basically what I need to do is multiply both sides by 432 pi times 432 pi. That gets rid of this. And then 1/6 of 432. I can do my calculator, so 432 divided by 6 is 72. So that is 72 pi. Okay, so that is the area of the slice. So we're almost there. Now we can subtract 72 pi out of the 144 root 3. That was the area of the entire quadrilateral. So it's messy. If you were just in math class and they just asked you for the final answer without any rounding, you would have to put it as 144 root 3 minus 72 pi. But this question wants us to round to the nearest hundredth. So we're going to need to just put this in the calculator and let it do the work for us. So 144 root 3 minus 72 pi. So we can do all that in the calculator. 144 radical 3, and we got to click out of the radical there. Be careful with that. So 72 and pi is right down there. So that becomes 23 and then 0.22 because we're going to the nearest hundredth. So that is our final answer. Woo! It's a lot. It's a lot. This is a very difficult question, but what do we really use? We use things that we would use on lots of very common SAT questions. We use area of a sector. We use 30, 60, 90 right triangles. We use tangent lines. We used area of triangles. We used things that are going to individually be on lots of different questions. And then what the SAT did to make this crazy hard is bring them all together, and we've got to move between them. But anytime you've got a hard geometry question with circles, I suggest drawing radiuses, making triangles. Odds are good. In some way, that will get you to the answer. I hope this helped.
Hi everyone. In case you weren't able to tell by my normal noodly stature, that was not me just now. That was Mike from Settele Tutoring. Mike has a plethora of helpful SAT videos on his channel, so please do me a big solid and go subscribe to Settele Tutoring. The link will be in the description. Now, back to the video. Well, this video has been a roller coaster of emotions. We started off as Problem Sette, then we were Problem Settele, and now we're basically just Problem Scuffed because Hurricane Helene has caused power outages in my state. So it's a little bit of an unusual setup. Comment below if you think my satellite internet is going to be fast enough to upload this video to you in time for the October test. Let's get started with question 2. Okay, question 2. So first thing I want to do, I noticed that square root is completely isolated on the right side, so I want to get rid of that. So I'm going to square both sides. And I get the square root kind of goes away. And we get 3k minus 2x over here. And then on the left side, I got to do 23 minus 7x times 23 minus 7x. So let's see, negative 7x, that's 49x squared. And then we've got, what's 23 times 7? 161. So we've got minus 161x, minus 161, that's minus 322x. And then 23 times 23 is 529, plus 529. Again, all we're doing is just foiling. I just did that kind of fast. If you go through and do the first, and then the outer, the inner, and the last, and then you combine all them, you should get what I have written over there, 529. Let me make that look a little nicer. Okay, you can hopefully kind of see where this is going. We're going to get this in standard form, and then we're going to use the discriminant. So, I'm going to add 2x to both sides to get everything to the left side. And then I'm also going to subtract 3k from both sides. And these two guys will go away. And we are left with 0 over here, 49x squared minus 320x plus 529 minus 3k is equal to 0. Now we're going to quickly identify A, B, and C. So A is 49, B is negative 320, and C is the constant term. So anything without an x is part of the constant term. Neither of these guys have an x, so they're both part of the constant term. And now we're going to use the discriminant, which I cover in my first short called the discriminant. So go to my shorts tab and sort by oldest. It's the very first one, very helpful. So the question says that it has exactly one real solution. So if you watch that short, that means that the discriminant tells us that b squared minus 4ac is equal to 0. Okay, so b is the green, so we're going to do negative 320 squared minus 4 times a is 49, and then c is 529 minus 3k. So all those colors, I just put those in there. Now I'm going to use calculator to help me with this arithmetic. So negative 320 squared is 102400. Negative 4 times 49 is negative 196. Just going to do that in 2 steps so no one gets confused. And now I'm going to do negative 196 times 529 to distribute. Okay, so I get 102400 minus 103684, and then negative 196 times negative 3, so that's plus 588k equals 0. And now I'm going to combine the like terms, so 102400 minus 103684, that's negative 1284 plus 588k equals 0. So this means that if I add 1284 to both sides, I get 588k equals 1284. And I'm just going to do this on a calculator. You can do this on Desmos. I'm getting k is equal to 107 over 49. So that would not fit in the Blue Book app. However, you'll notice if you look at the question, it says that we want to find the value of 56k. So we're going to do that right now. So 56k is equal to that times 56, which is telling me 856 over 7. And that is the answer. Let's at least jump to Desmos to verify that we did it right. Okay, so you'll see here, guys, that I typed in the left-hand side and the right-hand side of the equation. I typed in our answer, k equals for k, which was 107 over 49. You can see that 56k is 856 over 7. And I put the decimal answers down there. But most importantly, we take away from this, guys, is that the question wanted us to have a graph with one solution. So you see, it's a little tough to tell, and Desmos can get a little finicky with tangent lines, but maybe if I finagle it like just right, it'll show it to me. But it should touch that line at just one point, which means we have one solution. Great, let's keep going. Okay, before we move on, guys, I think I actually did get just the right zoom for it to tell me the solution. So you see it meets once and just at that point right there. Great, let's move on. Okay, question 3. So I cover these in great detail in my Ottocento, I think it's number 17, called Constants on Display. You should also check out my shorts, which go over this concept. There's 3 of them, 3 shorts on exponentials plus time. That goes over the equation that this problem is testing you on. Okay, so that equation, you can go watch that, is y equals a times b to the t over n, but I guess for this problem, it's not a word problem, so I'll just use x. Go watch those videos, but a is the initial value, b is the multiplier, and n is the interval, how often that is happening. So you see here, this is kind of phrased like that is the interval. That is literally how the SAT phrases the interval, the n. So that is going to go here. The a, we can kind of tell by looking at all the answer choices. That's got to be 13. And then the multiplier, we don't know. The question's asking us about that. It says increases by a factor of m. If I say increases by 2, that means you added 2. But if I say increases by a factor of 2, that means you multiply by 2. So pay close attention to that word factor. It's a multiplication word. Anyway, so the equation should look something like this. 13 m, and then to the x over 1/4. Now, when we divide by a fraction, that's the same thing as multiplying by the reciprocal. So the SAT won't write it like that. They'll write it like this. 13. I go over this in those shorts. Please go watch those shorts. So 1/4, the reciprocal of it is 4 over 1, or 4. So this would be 4 over 1 times x, or just 4x. So we want an equation that looks something like this to figure out what m is. It's kind of hard to tell which one's going to give me that answer. So I'm going to do something a little unusual here. Why don't we go and solve it on Desmos first, and then we'll come back and talk about maybe how I would do it by hand. Okay, guys, so I just went, they're all equivalent forms, so it doesn't matter. This isn't necessarily the answer. This is going to help us figure out the answer. So you can just pick whichever choice you want if you're going to use Desmos. I just picked a really messy looking one just to illustrate to you guys that it works no matter which one you pick. So it says for each increase in the value of x by 1/4. So maybe what I would do is I would make like x equals like 0 or 1, and then make x equals 1/4 and kind of see what happens. However, that's a very like narrow graph, and it's going to be really hard for me to like zoom in and click on those. So since we're dealing with x values, why don't we just use function notation? So why don't I start at 0 and then increase x by 1/4. 0 plus 1/4 is 1/4. And then the quotient of those two y values will give you the factor by which it was multiplied. So 130, new divided by old, 130 divided by 13, we get 10. So we just deduced that m is equal to 10. Let's go back and tackle the rest of the question. Okay, so now that we got that, m is equal to 10, we want to know which of the following displays m as a constant or coefficient. I go over this in the constants on display video. All we're looking for is some kind of answer choice that has a 10 visibly on display. That's what it means. Can you see a 10 anywhere? And hopefully you guys are seeing the only one that has a 10 is C. So C is the answer. Now, if I were going to do this by hand, I would maybe try to manipulate all of these and into a way that would give me this 4x that we want at the top, right? So I don't know, A and C are both standing out as pretty good options. So you see, like if you manipulate C, rules of exponent says, okay, 2/3 to the 6x, so we multiply those together. 2/3 times 6x is 4x. So you could go, oh, okay, so when x goes up by 1/4, that's what the 4x means that we were just talking about. Y gets multiplied by 10. You also could have done it with this one. So maybe you could have did 13 times, you can make the 110 squared to the 2x. Because 100, it's like, it's already, we don't want a 2x, we want a 4x. Oh, and you see power to a power, we get 13 times 10 to the 4x. This one was really hard to see without using Desmos, so I highly suggest you get comfortable using Desmos just in case you get stuck. Great, let's keep going. Okay, question 4. I'm sorry if this is a little confusing, guys. I maybe should have said juice concentrate. Basically, like, we're mixing 2 different cups of juice, each with different levels of concentrate and water mixed in them. So when I say juice here, I guess I really mean like pure juice concentrate, like orange juice concentrate. Anyway, the wording is very similar to a question in the Blue Book app. This is called a mixing problem. I don't have a video on this yet. I think this would be great for a short because I don't think it takes too long to explain. So here's what I do for these. So I just write 2 equations and then I use Desmos. That's it. So let's say I have P1 x1 plus P2 x2 equals P total x total. That's like a balance on the component. In this case, the juice concentrate, right? The thing that's in the mixture that we're measuring its concentration, in this case, juice, right? And then the you do another balance on the total volume. Oh, that should say x total. There we go. So another balance on the total amount of volume. Think about it. If I have 2 cups of water, 3 cups of water, I mix them together, I should get 5 cups, right? That's basically what the second balance is saying. So, so x1 plus x2 equals x total. So we're going to write these 2 equations, and then we're going to put them in Desmos. That's it. So the first balance is going to be the balance on the juice, and the second balance is going to be the balance on like the total liquid. right? Total volume. Okay, so I'm going to make solution A the first one. So it says solution A was 24% juice by volume. So 24%, if you divide by 100, that's 0.24. So I'm going to do 0.24. And then we don't know how much of solution A is in it. So I'm going to call that X. I'm going to use X and Y so that we can plot it on Desmos. And then the question says 64% for solution B. Okay, so let's do 0.64. 64 divided by 100 is 0.64. And then why don't I call the volume of solution B, why don't I call that Y? And then it says the total percentage of the mixture, right? That's what I mean when I say total. The final mixture has a percentage of 45%. So we're going to do 0.45. And then the total volume, which is 125, it says that. Okay, so that's my first equation. Now we're going to do a balance on the total volume. So x1 plus x2, well, in this case, that's just x plus y. That's the x is the amount we defined in solution A, the total volume in solution A. Y is the volume in solution B. And the final mixture, the new solution, has a volume of 125 liters. So x plus y equals 125. So there's still more to do after this, but let's go to Desmos, quickly figure out what x and y are. Okay, guys, so really all I did was type those two equations in, and now I'm just going to click on where they meet. And we just figured out that X, the total liquid in solution A, is 59.375, and the total liquid in solution B is 65.625. Let's carry on. Okay, so now the question is asking us, if you look up here, you see it's not asking about the total volume in solution A. It's just asking about the component volume, in this case, the juice volume in solution A, and the juice volume in solution B. So the juice volume is 24% of that. So 24% of 59.375. You do 24 divided by 100. 0.24 times 59.375. It's basically just that first term up here. I'm getting 14.25. That's how much juice, so we'll call that A. That's how much juice is in the pure juice concentrate, is in the first one. And then the second one is 64%. So 64% of that number, 65.625. So let's do that, 0.64 times 65.625. And I'm getting 42. So there's 42, I think, liters of juice in the second one. And now we get this nice follow-up question. A is P% less than B. Okay, so A is P% less than B. So this is essentially asking us to do the percent change from values, and it's percent less is a decrease. So that means we're going to make the quote unquote old this one, and then when we go this way, we get smaller. So this will be the new. I'm going to do the rest of this calculation on Desmos using the percent change formula. Let's go do that. Okay, so you'll notice that, man, Desmos is really helpful here. I was able to quickly do that percent of. If you just type in 24 and then percent, it'll put percent of. And the percent change formula, I go over this in my percents video, is new minus old over old times 100. So I just did that, and minus O over O times 100. And you get a negative number, but notice how the question said P% less. So you're never going to need to put the negative for a percent decrease. You just phrase that as a decrease. So if you get negative 25, you don't say negative 25. You would say negative 25%, which is a 25% decrease. So the answer on that today would be 25. They're never going to want you to put that negative. You just need to know what it means. Okay, so anyway, so when I rounded that to the hundredth place, as the question said, you'll see below I got 66.07. And I believe that is the answer. Let's keep going. Okay, question 5. Really the only relevant, it's not super relevant, but really the only relevant like prior viewing is probably my Ottocento on area and volume scale factors. That's definitely one of my most important videos if you're going for a 700 plus. I mean, if you're not, don't worry about it because it's not a super common topic. It's called area and volume scale factors. Okay, so probably the most challenging part about this is just making the drawing. So I'm going to draw a big right triangle. That's what they want me to do, right? And it says F is the right angle. So I'm putting F here. And then D, and then when I call this guy E, doesn't matter as long as you're consistent with what the problem tells you. Point Q lies on DE. So I'm going to put that, how about here? And then point J lies on EF such that it forms a parallel line. So I'm going to put it like right here below. So this is point J. And then I'm going to connect them. And it says it's parallel to DF. So that guy's parallel to this guy. And you see we got a triangle within a triangle. The parallel lines means a bunch of the angles are going to be the same. So these are two similar triangles. So almost anytime you got a triangle within a triangle on the SAT, you should be thinking of similar triangles. So let's just write that down. They're similar. And to make it clearer going forward, I'm going to, how about circle the first guy, the small triangle, in yellow, and I'll circle the big one in green. Okay, so it says that the length of EF is 45, so that is this entire side. And the length of FJ, that's this one, is 24. Okay, and the area of triangle DF, okay, we'll get to that, but here's the big trap, right? Lots of people, and I did this on purpose, lots of people would do like 45 divided by 24 and then use that to start doing proportions. But that is wrong. Do you notice how E, F, J, and DQ are not sides of a triangle? They're sides of a trapezoid. So you can't use those in your similar triangle proportions. We have to do subtraction and find this one. So let's do that. So 45 minus 24, that is 21. And we're going to use these two as our defined ratio to help us figure more stuff out about the problem. But first, let's tackle this thing where it says the area of a triangle DEF is 630 square units. So the area of a triangle formula on the reference sheet is 1/2 base times height. And when you have a right triangle, the area is just 1/2 times the two legs. So this side and this side. So we're going to do 630 equals 1/2. The base is 45 for the big triangle. And then the height for the big triangle is DF. So I'm going to multiply both sides by 2. I get 630 times 2. That's 1260. You could just divide by 1/2, whichever is easier. And I get 1260. And then I'm going to divide both sides by 45. And I get 28 is equal to DF. So this whole guy here is 28. And how about, while I'm at it, I'm going to do Pythagorean theorem on the big triangle and find the hypotenuse DE. So why don't I just do that down here? So a squared plus b squared equals c squared. So 45 squared plus 28 squared equals DE squared. 45 squared plus 28 squared, that's 2809. Then I take the square root of both sides. and I get 53 is equal to DE. Okay, so this guy is equal to 53. So now at this point, I have two options. I don't know, there's probably a bunch of ways to do this, but this is what I'm thinking. So we could set up proportions or scale factors, whatever, and find the sides of the yellow triangle to find the perimeter of QEJ. Or how about this? We use the knowledge from area and volume scale factors, make it a little bit less work. We find the perimeter of the big one, and then the linear scale factor, the ratio of the lengths, as I talk about in OCT number 10, is the same as the ratio of the perimeters. So let's find the perimeter of the big triangle. So the perimeter of DEF is equal to, we're going to do 28 plus 45 plus 53. And what is that? That's 126. And now we just need to find the ratio of the sides. And the only sides we currently have, as we talked about, are this one and this one. So in my scale factor video, I talk about how K is equal to big over small. Big length over small length. The linear scale factor is big linear measurement over small linear measurement. So 45 over 21. That simplifies to 15 over 7. So the linear scale factor is 15 over 7. The perimeters use the same scale factor because the perimeter is just a sum of one-dimensional measurements. So we've got the big perimeter, and we've got the way I've defined the scale factor. We're going to do, to find the small perimeter, we're going to take that big perimeter, and then you got to think, do I multiply or divide by the 15/7? So we're going to divide by 15/7 because we're going to make it smaller the way we defined it. And 126 divided by 15/7, that is 294 over 5. That should also give you 58.8. And that is the answer. Okay, question 6. So I have a video going over this exact type of question. You should definitely check it out. It's called Ottocento, I think it's number 14, matching coefficients and clearing denominators. I go over this in great detail there. I don't want to waste time, so I'm just going to assume you've already watched it. So do you see here, this stuff over here doesn't really matter. We'll talk about that more later. But you see here it says the equation is true for all values of x. That means it has infinitely many solutions. So the left-hand side and the right-hand side should be pretty much the same. So first thing we're going to do is find the least common denominator. Well, hopefully you kind of see the least common denominator is probably that denominator on the right side. And indeed it is, without going into too much detail about that. Usually the LCDs on the SAT, when it comes to algebraic LCDs, are pretty straightforward. They're not trying to trick you, but there's plenty of videos on YouTube going over that, including the one I have above, if you want to dive into that more. So the least common denominator is ax minus 5 times 2x plus 3b. So we're going to multiply the whole thing by ax minus 5 times 2x plus 3b. So the ax, if we do this to the first one, the ax minus 5s will go away. And we're left with 3x times 2x plus 3b. And then we have minus, when we do it here, these guys go away, and we're left with 7 times ax minus 5. And then when we do it to the right side, both these guys go away, and we're just left with that big mess. So 6x squared plus 5x plus a plus b. Okay, now we're going to start getting the left-hand side in standard form so that we can match the coefficients. So we've got 3x times 2x, that's 6x squared plus 9bx And then negative 7 times ax, that's minus 7ax. Negative 7 times negative 5, that's plus 35. Equals 6x squared plus 5x plus a plus b. Okay, now we're going to do matching coefficients. So I'm going to highlight them all just to make it most clear. So those are the x squareds. Those are all the coefficients of x. And then the constant terms are just anything without an x. So we look at the x squareds, and we get 6 equals 6. That doesn't really tell us much. For the x's, though, we get 9b minus 7a is equal to 5. And then for the constants, we get 35 is equal to a plus b. And you see the 6 equals 6, this doesn't really tell us anything. So it's not wrong, it's just not really helpful. But those second two, these guys form a 2x2 system. And you can solve this using whatever method you want. Let's, I don't know, how about I multiply the bottom one by 7 and then add them. So I'm going to do 9b minus 7a equals 5. And then a plus b equals 35. I'm going to multiply by 7. So 7a plus 7b equals, what's 35 times 7? This is called elimination. You could also just change the a's and b's to x's and y's and put it into Desmos. You can do that. All right, I'm going to add the two equations. The a's go away. And I get 9 plus 7, so that's 16b equals 250. And I divide both sides by 16, and I'm getting b is equal to 15.625. And now I'm going to go back to this one and put in b as 15.625. So 35 minus 15.625. And I get a is equal to, I just subtracted the b from both sides to get a. So a is equal to 19.375. And I believe the question wants b over a. So we're going to do b over a equals 15.625 over 19.375. I'll just do that on a calculator. 625 over 19.375. And I am getting 25 over 31. And that is the answer. Let's go to Desmos and verify that we did it correctly. Okay, guys, so you see I typed in the left-hand side. You could just use y equals, you don't have to use function notation. You can say y equals 3x, blah, blah, blah. Y equals blah, blah, blah. And I typed in a equals 19.375, b equals 15.625, which is what we got. B over a is 25 over 31. Here are the decimal answers, if you care about that. I have no idea why you would use the decimal answers, but people always ask me in the comments, so there you go. And I just want to show you, people are probably wondering, what did all that stuff at the beginning tell you? Like, oh, x is not equal to 5 over a. Basically, there's like either vertical asymptotes or holes, some kind of point where the function is undefined. And you can see when I type in 5 over a and negative 3b over 2, both sides of the equation are undefined. So it's really just context that doesn't matter to the question at all. But I just figured you might be wondering, hey, Kyle, what does that x is not equal to 5 over a means? Well, it means x cannot be equal to 5 over a. That's all they're telling you. It's not relevant to how you're going to tackle the question. So the answer is 25 over 31. Well, let's keep going. Oh yeah, I might have glossed over this, guys. Since I didn't type this in myself, always when you type it in, make sure that the second one perfectly replaces. So you see how the blue one, when I click on it, it perfectly replaces the red one. That means it has infinitely many solutions, which means it's true for all values of x, which is what the question said. Great, let's move on for real. Okay, question 7. So the really important thing you guys understand here about scatter plots is that the actual y values you get from the dots. So you see all these here and here and here, right? But the predicted y values you get from the line of best fit itself. So all the predicted y values are the y values coming from here. So if you wanted to find a predicted y value, you would find the line. So this question isn't that involved, but it's just confusing because of the wording. So I'm going to show you a surefire way to tackle the wording that helps me get it right every time. So what I do is I literally write down what it says in the question verbatim, picking out the keywords. So do you see here, it says the y value predicted is less the actual y value. So I'm going to write that down using math. So the predicted is less than the actual y value. So we're going to be counting dots. So this inequality will make way more sense if you flip the inequality around, okay? So I would always try, you don't always have to do that. Sometimes they give you actual on the left-hand side, but you see for this one, actual is not on the left-hand side. You want this inequality in terms of actual. So easy way to remember, alphabetical order, actual, predicted. So we're gonna flip this inequality. So I'm gonna switch it around so that actual is on the left and predicted is on the right, but now the sign needs to be flipped as well. And you see, if you kind of think about it like an alligator, it's like it's got to be eating the same guy, right? So flipping this inequality around and thinking about it in terms of actual is going to help us interpret it much easier. Now I go, oh, wait a minute. Now that I know actual is greater than predicted, I'm basically just counting how many dots are above the line. Greater means above the line. So many people, they would have just saw this less than and went, oh, let me count the ones below and get it wrong, right? So above the line, so that's 1, 2, 3, 4, 5, 6, 7. But that's not the answer because it's not asking how many. It says, this one's a little harder. It says, for what fraction of the data points? So we need to do that desired over the total number. So there's like 7 up here. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 down here. So in total, that's 7 plus 10, 17. So above the line, there are 7/17 of the data points, and that is the answer. And below the line, there is 10/17 of the data points. So that would be the answer if that was what they wanted. Now, they don't always ask you for the fractions. Sometimes the answer literally is just 7. It'll say, for how many of the data points? And you would just say 7. Or for how many of the data points the other way? You would just say 10. So just really be on your toes and pay close attention to the wording. Because if it mentions fraction, you got to put, or percentage, you got to put a fraction or a percentage. Although they don't always do that. So the answer to this guy is 7/17. Great, let's keep going. Hey everybody, thank you so much for watching until the very end of my video. And I want you to know that I'll be hosting an exam day live stream on Saturday, October 5th at around noon Eastern Time. If you want to get notified of that live stream, you can click here. And if you want to subscribe to Settele Tutoring, you can do that here. As always, I wish you the best of luck on your exam, and thanks for stopping by.